Welcome to the Bodhi Academy. My name is Amsha Klaso, and in today's video we will continue with our chapter Electric Current and its Effect, Class 7, Chapter 10. So previously in this chapter we saw the different symbols that are used for electric components such as battery, wires, switch on and switch off mode, bulb, all these symbols we saw. Then we saw what is a battery. So what is a battery? It is when two or more electric cells are connected together, it forms a battery. Then we also saw the heating effect of electric current. In this we saw that when current is passed through a wire, it ends up heating that wire, or even when electric current is passed which lights the bulb, that also causes heating of the bulb. Then we also saw what is a element. An element is a coil of wires, and we also saw the electric fuses that are used in our houses to take the load of electricity. Now today we will continue and will look at the magnetic effect of electric current. So now here in this activity what they have done is they have taken a cardboard box, they have placed a magnetic needle inside it, okay, and they have formed a complete circuit. Here there is a cell and there is the switchboard and there is a bulb over here. So now what they are doing is that anytime the switch is turned on, we see that there is some kind of deflection that is happening on the magnetic needle. So now the question was, why was this happening? So now we know that a magnetic needle, it only deflects when you get another magnet close to it. So there is some kind of deflection that happens. But here there was no another magnet that was got close to that magnetic needle. So why was this happening? So we know that what we have done here is that we are passing current or electricity through this wire. So now can we say that when we pass current through this wire acts as a magnet? Yes, it makes sense, right? Or else in no other situation would this needle deflect. Somewhere after passing current through this wire tends to act as a magnet, and therefore there is some kind of deflection that happens in this magnetic needle. So that is what was happening here. So this is what a scientist called Hans Christian Ørsted also wondered. He was the first person who noticed the deflection of compass needle every time the current was passed through the wire. So he was the scientist who first noticed this deflection, that every time there was current being passed, there was some kind of deflection happening to the compass needle. So when electric current passes through a wire, it behaves like a magnet. This is the magnetic effect of the electric current. So whenever electric current is passing through a wire, it acts as a magnet, and this effect is called as the magnetic effect of electric current. In fact, any electric current can be used to make magnets. Do you find it too surprising? Let us try it out. So now in this activity again they have used a nail and they have placed some pins over here. So what they have done, or what they notice, is that when the switch is turned on, when electricity is passed, these pins which are there, they come towards the nail and they get attached to it. So what we can conclude here is that this also acts as this nail also acts as a magnet, but it acts as a electromagnet. So the coil in the above activity behaves like a magnet when electric current flows through it. When electric current is switched off, the coil generally loses its magnetism. This coil they are talking about. So this nail is wrapped up with wires which forms this coil. So what they are saying, when electric current is passed, these pins get attracted towards this coil. So that is when they act as a magnet. The minute this power is switched off or the current is taken off, these pins, they lose their magnetism. Such coils, they are called as electromagnets. The electromagnets can be made very strong and can lift very heavy loads. Do you remember the crane which you read in chapter 10 of class 6? So now we have seen those cranes, right, they have very high level of electromagnets. That is why they can remove magnetic material from any junk. Even doctors, they use tiny electromagnets to take out small pieces of magnetic material that might have accidentally fallen into your eyes. Many toys also have electromagnets inside. Now let's look at an electric bell. Now we all have seen an electric bell, but how many of us really know how these electric bells work? So we are quite familiar with an electric bell. It has an electromagnet in it. So electric bells, they have what? They have the electromagnet placed inside. Now figure 10.20 shows the circuit of an electric bell. So this is the electric bell. It consists of a coil of wires wounded on a iron piece. So here you see, this is the iron piece and this is the coil of wires that are wrapped around. The coil acts as an electromagnet. So this coil which is there, this acts as an electromagnet. An iron strip with a hammer on one side is kept close to the electromagnet. So this is the hammer like thing which has the iron strip. So there is a contact screw near the iron strip. So see here, this screw, this is the contact screw that is there near the iron plate. When the iron strip is in contact with the screw, the current flows through the coil which becomes an electromagnet. It then pulls the iron strip. So what happens is, when current is being supplied from here, what it does is that the strip comes in contact with the screw. This strip comes in contact with the screw, okay, and it becomes, that coil over here, it becomes the electromagnet. It then pulls the iron strip. So it pulls this iron strip. In the process, the hammer at the end of the strip strikes the gong of the bell to produce a sound. This is the gong. So due to that push and pull that is happening of the strip and the iron nail, this hammer like which is there, it repeatedly goes and hits the gong of the bell. However, when the electromagnet pulls the iron strip, it also breaks the circuit. The current through the coil stops flowing. Will the coil remain an electromagnet? No. So in this case, what will happen? The current supply will stop, and therefore this will no longer be an electromagnet. It no longer attracts the iron strip. The iron strip comes back to its original position. So it comes back over here and touches the contact screw again. This completes the circuit. The current flows in the coil and the hammer strikes the gong again. This process is repeated in quick succession. The hammer strikes the gong every time the circuit is completed. This is how the bell rings. So every time the same process repeats, and this happens so fast. We have noticed that the bell rings very fast. No, we cannot hear that break when that strip is getting disconnected from the screw. That gap or that pause we don't see. It is a continuous process. So it happens very, very quickly. Okay. So this was about the electric bell. So now in this chapter, what we have learned is that it is convenient to represent electric components by symbols. Using this, an electric circuit can be represented by a circuit diagram. So what they are saying is that using electric components, it is much simpler or easier to draw the circuit. It is like smaller symbols that you are using. You are not drawing a whole big circuit showing everything. So when an electric current flows through a wire, the wire gets heated, and this is known as the heating effect of current. This effect has many applications. Wires made from some special materials, they melt quickly and they break when large electric currents are passed through them. That is, when a wire has a certain limit. The moment you cross that limit and you supply extra current, that wire either breaks or it melts down. These materials are used for making electric fuses which prevent fires and damage to electrical appliances. When an electric current flows through a wire, it behaves like a magnet. So this we have seen in the electromagnet. When you pass electric current, the wire will begin to act like a magnet. A current carrying coil of an insulated wire wrapped around a piece of iron, it is called as a electromagnet. Electromagnets are used in many devices. So that was it for this chapter. Please don't forget to like, share and subscribe to the Bodhi Academy.